In this video, I just wanted to review a little bit about mean value theorem. The mean value theorem states that if a function is continuous and differentiable, and I'm going to just make that note, it has to be continuous and it has to be differentiable. If a function is continuous and differentiable, then somewhere on the interval from a to b, there must be a spot where the slope of the tangent line is parallel to the slope of the secant line that connects the endpoints. So you can see here that we found the slope between the endpoints, right? Here's the point B, f of B. Here's the point A, f of A. So we found the average rate of change. And of course, the derivative gives the instantaneous rate of change. So the mean value theorem says that if a function is continuous and differentiable on an interval, then somewhere between the two endpoints, the instantaneous rate of change has to be equal to the average rate of change. Another way of saying is the tangent line has to be parallel to the secant line. Okay. So find the value c that satisfies the mean value theorem for that function on the interval from 2 to 5. First, we should just verify that 2 over x squared is continuous and differentiable. Think about what 2 over x squared would look like on a quick graph. It would look something like this. So it's not continuous and differentiable everywhere, but on the interval 2 to 5, it is. From 2 to 5, it is differentiable. First thing let's do is find the average rate of change. So average rate of change on the interval from 2 to 5, well, of course, we know the x values, right? We're talking about going from 2 to 5, so those are the x values. To get the y values, we have to plug 2 and 5 in. So 2 over 5 squared minus 2 over 2 squared. Now, we certainly could do this by getting a common denominator and saying if I multiplied this by 4, multiplied this by 25, so I'd have over 100 minus 50 over 100, so that would be negative 42 over 100, but of course I'm also dividing by 3. That's the same as multiplying by 1/3. So that's 14 over 100, negative 14 over 100, or negative 7/50. This is my average rate of change. Okay, so that, obviously I could do it on this picture right here. This represents the slope between the endpoints, like that. Or in this picture, it represents the secant slope, like that. Now, mean value theorem says there, because it's continuous and differentiable, there must be a spot where the derivative is equal to that. Well, the derivative of 2 over x squared, let's start by just rewriting that as 2x to the negative second. So the derivative would be negative 4x to the negative third, or negative 4 over x cubed. Now, a lot of times the mean value theorem is done with this variable c just to say that it's an x value that's between a and b. So you could certainly come over here and say, well, I'm going to say negative 4 over that value c cubed. You could also leave it as x cubed. It really wouldn't matter. So let's do a little bit of cross multiplying here. We'd have negative 7c cubed equals negative 200. Divide both sides by negative 7 and take the cube root. So my answer would come out to be, actually let me put it up here where I got a little more room. C would be the cube root of 200 over 7. And that is approximately 3.057. So you do see it is in the interval from 2 to 5. It has to be an inside point. It has to be between 2 and 5. It couldn't be an end point, but that will be my value.